Okay, we're going on now to the PowerPoint slides of section 9.4. Properties of logarithmic functions, again, the products, the powers, the quotients, and then using properties together. Now, I just finished doing the textbook where we looked at the actual pages of your textbook online, and I've gone through those. Again, I didn't read every single word, but I tried to interpret it somewhat, but it's a little more intensive than this, which will just be your outline. So as we look at logarithms of products, the first property we discuss is related to the product rule of exponents. That is, if your bases are the same and you are multiplying them and they have exponents, you just add the exponents and you get this. Now, the product rule for logarithms, it's for any positive numbers, m and n, and where a, which is our base, does not equal 1, we have this, in which, remember, this means m times n. So the proper way to write this, sort of extending it a little bit, is to write it the log base a of m. Now, because this is multiplication, we are going to add plus the log base a of n. So again, in your notes, I would strongly advise you to write this down. The logarithm of a product is the sum of the logarithms of the factors. We'll give you an example of this shortly here. So how about if we have something like this? How would you write that? Well, again, it will be log base 3 of 9 plus log base 3 of 27. And here we will get, and I could just show you something here too. This would be log, or let me take a step back here. And teasing this apart for you, reflecting on what we did in section 9.1, that this is our base 3 that will be raised to some exponent to give us 9. So what will the exponent be? 2. And this is base 3 raised to some exponent to give you 27. What exponent will this be? 3. So if we were to add our exponents, which would look like this, 3 to the second times 3 to the third, we get 3 to the fifth. And if we multiply, and let me get my calculator up and running, 9 times 27, this will give us 243, which is 3 to the fifth power. So the logs then of these, which would be a 2 and a 3, would give us this particular answer. All right, let's see what they have written here. All right, we've done that. Now remember, if you multiply these two together, you get this. And again, that would be 3 to the second, 3 to the third gives us 3 to the fifth, which is 243. So the log of this is 2. That would be the exponent that we are going to raise 3 to get our 9. And here, 3 to what exponent? 3. And that gives us then 3 to the second equals 9. 3 to the third is 27. So again, teasing this apart and showing you that this is a legitimate way of writing an equivalent expression of that. Going on. Now, express as an equivalent expression, that is a single logarithm for this. So this would be log, our base is a, and it will be six times 7. We're just moving this into a common parenthesis, which in a sense could be log of base a, and this will be 42. Which is what we've done, which is this. Okay? Now, keep in mind, as you take notes on this, that you can also reverse this, that this would become this, and this would become this. We'll keep that in mind. Okay, logarithms of powers. The second basic property is related to the power rule. That is, when you have something set up like so, a to the m raised to the n power, we multiply our exponents and we get a to the mn. All right, the rule is we multiply here. So for any positive number m, and a again does not equal 1, and any real number p, we're going to raise this number to an exponent. So what do we do? Well, the key here is we will then take our p and move it to the front of our log expression. And that's what they've done. They've moved the p to the front. So the logarithm of a power of m is the exponent, which is our p, times the logarithm of m. So we're going to multiply this by our exponent. And we'll see examples of this too as we go on here. So let's work these out here. We want to write these as an equivalent log expression. So we're going to take our exponent, -3 log of a to the log base a of 6. So that is this one. Now for our example in B, we want to convert this, which is in our base here, to something with an exponent. So this becomes log of 4, base 4, to this. And what is this in this is its radical form. What is it in its exponential form? Well, it's x to the 1/2 power. Remember, we said 1/2 is the square root of something. So now we can write it. Our exponent is 1/2 that we put in front, log base 4 of x. So once again, we're using this power rule to rewrite equivalent expressions as a product. So this would be a -3 times this. The exponent just goes to the front. And here we had to change our radical to an exponent form, x to the 1/2. So we can take the 1/2 and move it to the front, which is what we've done. So we're taking our negative exponent, moving it to the front. We had to convert this to 1/2, and again, I don't like the way they've written that, and just move it to the front of it. I don't know why they do that diagonal line, but it's 1/2. Okay? So again, take some notes so you know, you see an example of the rule that you are applying. All right, continuing, logarithms of quotients now. The third property that we study is similar to the quotient rule of exponents. So a to the m divided by a to the n, the exponent, when it crosses this division bar, changes its sign and becomes a negative. That is, we're going to subtract exponents. And in log form, when we have positive numbers and a is not equal to 1, we just take this. Oh, didn't want to do there. There we go. We take this and then we subtract it from that. So this, let me get a pen going here. We're going to take this, move it up, and we subtract it. But we put it in log form. Okay? So anytime we see a negative there, we're knowing it was, in a sense, in a fractional form originally. Now we can go on. So let's write this one out. And again, I'll write it out the proper way. Log of base 3, and then it's 9 over y. So the equivalence of this would be log base 3 of 9 minus log of base 3 y. So this is equivalent to this. Now we're learning these skills so that later we can handle equations that they give us where we have to figure these things out. And again, this is 9 over y. And they write it the way I don't like, but that's okay. All right, let's do this one. We're going to reverse it. So this would be log base a, and we're going to have a fraction now, and it will be 6/7. So again, we're reversing what we just did. If it looked like that, we can condense it into this, And if we wanted to get an equivalent expression, it would be this. Again, take notes. And again, 6 over 7 in reverse. Now, using the properties together, we want to write as an equivalent expression using individual logarithms of x, y, and z. So, now this is an exponent, 3. So we're going to put that out in front, 3 of log 4 base 4 of x. Now these are going to be negative log of base 4 of, well, I don't put the of in there, log base 4 of y, and then log minus, because it's in the denominator, log base 4 of z. So this is my A equivalent expression. So again, the exponent goes out in front because we're going to times this by 3. There's our log base 4. And then since these are in the denominator, they're both going to be negative. All right, for this one, we have to fiddle with it a little bit first. Log of base of b, log base b. And then what is this? The third root of something. Well, we're going to write that third root of something as a 1/3 exponent. The third root of something is 1/3. This is from chapter 7. And then we get x, y, and we get z to the 7th. I'll change colors so we don't get it mixed up here. So this is 1/3 of the whole thing. So let me write it down here. It'll be 1/3 of the whole thing. So that's where you get these big parentheses here. Now it's going to be the log of b here, and it's going to be an x plus the log base b of y, and then this is in the denominator, so it's going to be minus, but what is the exponent? The exponent is 7, so minus 7 log base b of z. And there it is. So again, if you want to see it done again, go back and watch it. Or initially go back to where these are just showing by themselves and see if you can get these out of it. And they do give us the answers as well. There's A. Now this is not finished yet because we have to separate these two. There's our 3. And then we have to finish that as well. Okay. Now you could have used a negative, put these two together, or you could just do it as I've done it, distribute the negative. Negative goes there, negative goes there. You don't need the parenthesis. Oh, okay, they're showing it here. All right, this one's maybe even better than mine, but mine was done live. All right, here's this one that they're converting to, again, 1/3. The cube root of something is 1/3. Then it's 1/3 of all of this. And then, again, they're doing it a little differently than I did it, but eventually they get to where we were. And writing that Z, again, I'd use cursive in handwriting. Otherwise, you know, that looks like a 2 if you don't make a Z carefully there. And again, you could use those extra parentheses in there, but you need just to be careful of it. Okay, now what we're going to do is express as an equivalent expression that is a single logarithm all of this. So let's look at it here. Since it's 1/3, it's going to be log of log base b, and then the 1/3 indicates it's the third root of something. And since there is a negative here, and there is let's write this one out. Well, because this is lots of writing, let's see if we can follow it through. So there we have that. Now I need to convert this 1/3 as an exponent of x, which I will make there as x to the 1/3. And this -2, I'm going to convert this 2 to an exponent of y. So this becomes our 2 there. I'm keeping my negative because that's telling me that's going to go in the denominator. And then this is just written this way. That's fine. Now, I'm going to put this over this. So I'm bringing this down to our denominator. And I just have that. Now, what is the third root of x? Well, x to the 1/3 is the third root of x. And that's going to be over y to the second. And then this z, I could put here as times z out here, or I could, again, it could be out there, this z could be out there, or, again, as we mentioned in our textbook lesson, more often it's placed in front of the radical. So I'll erase that z there so you don't get confused. So this goes through these stages and becomes this as your final answer. Okay, that was helpful. And then the last thing we're going to do is the logarithms of the base to an exponent. For any base a, which is right here, if we have a to exponent k, this over here, let me just go over that with you, log of a to a. Suppose it was just that. Well, this, interestingly, just equals 1. So if we have something like that to the k power, we're saying this is a 1, 1, and then that equals k, then what happens is k, well, this equals k. So whatever value we have in the k position, let's say it's a 5, this will be 5. Why? Because this part is 1. And that's what we're saying. So, again, at least this part's a little bit easier, or maybe, but just follow the pattern. Remember, this is log base 6 of 6. This part here is going to be a 1, so we end up with 8. 8 is our k, and we said that when it's like this, it just equals the k, which is 8. So this one is just going to be an 8. And this one is just going to be a negative 3.4. So if you see it in this form, log of a, log base a of a is equal to something up here that will just equal k. Whatever's in that position, that exponential position there, that is the answer to this. And let's see it in action here. Again, it looks easy as long as you know the form. And again, for this one, it's just what's in the k position is k, so 8 equals 8. Why? And again, because this is all 1. This is a 1, and it equals that. Okay, so here's like a little summation that if you want to put them in your notes, when you have this, this is the product. We just put a plus between them and write it. Here, if this is raised to a power, we just put the p in front of the log out there. They're showing it here. If it's division, we're going to convert it to subtraction. And then if it's a log base a of a to the k power, it just equals k. This would be a very good summation to have in your notes, and you should probably pause it to write it down. And that'll wind this up.